Today we're going to be looking at a feature put out by the Royal Society of Chemistry called ChemSpider. If you point your browser to www.chemspider.com, you'll come to this great search engine. And today we're going to look at the structure feature on that search engine. If I click on structure, I get a window where I can draw chemical structures, and there may be a drawing in there already if you've already used this program before. I can get rid of a previous drawing by highlighting and hitting the broom feature, or by hitting the new feature and getting a new page. We're going to draw a structural isomer of octane today that will have 8 carbons in it in some random pattern. I'm going to click on the single bond tool. When I click in the drawing portion, I get a single bond between 2 carbon atoms. And if I highlight over a carbon, I get a green circle where I can click and drag, click and drag, click and drag, making more single bonds. Notice that the angles in between the CH3s also indicate carbon atoms. Right now we have 1, 2, 3, 4, 5, 6 carbons in the structure. Here's a 7th carbon, and there's an 8th carbon. That should be a structural isomer of octane. Towards the top of the page, there's a clean feature, which if you click that, will redraw your structure in a more uniform pattern. Towards the bottom of the page, there's a search option. If I select all isomers, it's going to search for any compound that has the same number of carbons and hydrogens as what I've drawn. If I leave it at exact match, it's going to look for just the structure that I have. Select search. And the compound we drew was 3,4-dimethylhexane. If I want to know more about the properties of that compound, scroll down. There's a properties tab, and I get information like experimental boiling point. This compound boils somewhere between 117 and 119 degrees Celsius, depending upon the source of the information. And towards the top of the page again, if I hit the zoom button, I get a pop-out window that shows this compound in more detail up close. And if I collect 3D, then I get a 3D model of this molecule, which I can rotate and manipulate.